Okay, today we're learning our third method of solving proportions. If you remember, one of our methods was equivalent ratios. And what was my key word with equivalent ratios? I find the missing link between the sides of the ratio that I know. And then my second method was using algebra. And my key word for algebra was reciprocal, multiplying by the reciprocal. Now the third method is going to be using cross products. In cross products, I solve a proportion, and it's kind of, the word cross kind of hints at the way I'm going to do that. So I have a proportion 2/9 equals 3 over d. Well, I'm going to circle the parts of the ratio that are diagonal from each other, or cross from each other, across, and I'm going to multiply them together. That's where products comes in. So cross meaning diagonal, and products meaning that I multiply. Quentin, you need to have a piece of paper, a pencil, and your book open, please. All right, so we have 3 times 9 equals 2 times d. Do you agree that 2d, if I just write it like that, that's showing multiplication? You should, right? We all should know at this point that 2d means that I'm multiplying 2 times d. Right, Kevin? Okay. All right, so now 3 times 9 is 27 equals 2d. And what do I need to do to solve for d? Zach, what do I need to do to solve for d? Nope. No, what? Chris? Divide by 2. Very good. I need to divide both sides by 2. And then d equals 13.5. All right, any questions on that? I think I should have a few questions. Anybody have any questions? Chris?
So it doesn't matter, say, how you go back to 3 times 9 equals 3, it doesn't matter if 2d equals 3 times 9.
Okay, that's a very good question. Does it matter if I said 2d equals 3 times 9? Doesn't matter at all. As long as I'm multiplying 2 times d on one side and 3 times 9 on the other side, it doesn't matter which order I write them in. All right, very good question. Justin?
Where do we find where the number where we divide the other numbers by?
The number where we divide, you mean the 2? Like what?
How do we find it?
Because 2 times d is 2d. The whole goal is to get d by itself. Well, how do I get d by itself? I have to divide by 2. If that was 4d, I would divide by 4. If it was 8d, I would divide by 8. Whatever number is attached to my variable, that's what I divide by. Okay, good question. All right, now I want you to do the second one on your own, and then we'll work through it. All right, so the first thing I want to do is circle the parts of the proportion that I'm going to multiply, and now I'm going to write it out. Now, it doesn't matter. I could write it either way as long as I'm multiplying 5.5 times c and 2.2 times 11, okay? I could have said 2.2 times 11 equals 5.5c, okay? I could say it either way as long as I'm multiplying the correct terms together. So what's 2.2 times 11?
24.2.
Okay, very good, 24.2. So now I have 5.5c equals 24.2. Now what do I need to do to solve for c? What do I need to do to solve this proportion? Anybody think they know? Kevin?
Divide 5.5 each side.
Very good. Whatever is attached to my variable, you agree that I'm multiplying 5.5 times c, right? So I need to do the opposite operation to get c by itself. Divide both sides by 5.5, and c equals 4.4. And I box it in. All right, so that's how you would solve a proportion using cross products. Now, in example 2, this should look somewhat familiar because we had to write a proportion in 8.4 too, right? Does anybody remember what example we used?
Bagels.
Very good. I'm surprised nobody remembered first hour. We used the bagels, right? cost of bagels today to cost of bagels yesterday. Do you guys remember that? Okay, now what did I tell you? What was the most important thing about setting up that proportion? Anybody remember? What's the most important thing about setting up that proportion?
You have bagels to bagels and dollars to
Okay,
dollars.
very good. I'm glad one person remembers. Anybody else remember? Okay, then I'm comparing the same thing on both sides of this proportion. That's the most important part. Okay, now we could set this up several ways, but we've got to be comparing the same thing. Okay, so let's look at how we could set this up. Does anybody think they have an idea of a proportion that I could write from this table? Besides Chris? Anybody? No? All right, Chris, help us out.
Okay, 1/5,
105
over 17.5, and then 60 over W.
That's exactly how I would do it. Okay? Now, it's not the only way. I could have said a person's weight on Earth over a dog's weight on Earth equals a person's weight on the moon over a dog's weight on the moon. Does that make sense? That's how First Hour did it, actually. But it worked out. It'll work out any way that you set it up as long as you're comparing the same unit to each other. All right, now let's use cross products to solve this proportion. 105 times W and 60 times 17.5. So I have 105W equals 60 times 17.5. 60 times 17.5 is 1050. 105W equals 1050. And now what do I do to solve for W? Horsey?
Divide by 105.
Very good. I need to divide both sides by 105. That cancels. And W equals what? 10 pounds. So what am I saying? I'm saying that if a dog weighs 60 pounds on Earth, it's going to weigh 10 pounds on the moon. Okay? Now, I don't know if this formula is exactly accurate, scientifically accurate, like if there really is, but the whole point of it is setting up a proportion, comparing the same unit to each other, and then solving. Do you see, guys, do you see that? Because you're about to do one, okay? You're comparing person's weight on Earth to weight on moon and dog's weight on Earth to dog's weight on the moon. Do you see that, Quentin? All right, any other questions? Any questions? Okay, one more example. In example 3, now we're still writing and solving a proportion, but this one's going to have a few steps, and here's why. Okay, let's read it. It says penguin. It's a penguin example. At an aquarium, the ratio of rockhopper penguins to African penguins is 3 to 7. Okay? And it says, if there are 50 penguins, how many are rockhoppers? Well, I have an issue here. I have a problem here right from the beginning, and you should be reading the example with me along in your book on example 3. It gives me the ratio 3 to 7, right? 3 rockhoppers to 7 African penguins. Equals, I don't know how many rockhoppers, to 50 total penguins. Am I comparing the same unit?
No.
No, I'm not. Because here I'm comparing rockhopper to African, right? Here I'm comparing rockhopper to total penguins. So I'm not comparing the same amount on both sides of my proportion. What do I need to do to find the total of my smaller ratio? If there's 3 rockhoppers and there's 7 African, how many total penguins are there? 10. So that's the ratio that I need. The ratio of rockhoppers to total penguins for my smaller sample size. 3 to 10. Now I'm comparing rockhopper to total and rockhopper to total. You see that?
Oh, okay.
You see that? Before it was giving me rockhopper to African. Well, that's not what it was asking me to solve for. It gave me the total on the other side. So I've got to compare rock hopper to total and rock hopper to total. Okay? So it's very important that you're comparing the same unit. If you don't, you're going to get the wrong answer. Okay, so now you're going to use cross products to solve because that's what we're learning in this lesson. All right, so we have 10R equals 3 times 50. 10R equals 150. Divide both sides by 10. And R equals 15. 15 penguins, rock hoppers. All right. And if you understand that, that's everything you need to know for 8.5.